Hello everyone, welcome to Solve It Academy. So the topic is electric field lines. What are electric field lines first of all? Okay, yeah. Electric fields electric field lines are imaginary lines or curve drawn to region of space. So it must be space. Sorry for the inconvenience caused. Okay, right. Electric field lines are imaginary lines or curves drawn to the region of space so that its tangent at any point is in the direction of electric field vector at that point. See, in this electric field, it is positive charge and the electric field lines are represented like this. It means that they are representing the direction of the electric field at that point. If I am taking this point, the electric field is in this direction. It is showing me that. Okay, that is nothing but electric field lines, and these are imaginary lines. These are the imaginary lines, as we have know that these lines are like just magnetic field lines. Okay, number of lines crossing through unit area perpendicular to electric field is proportional to magnitude of electric field. This means that this statement means that number of lines crossing through unit area perpendicular to the electric field is proportional to magnitude of electric field. Means that if I am taking the electric field at this point, electric field at this point, and if I am taking electric field at this point, and these lines will only go here, like this, the lines will be there. Okay, this will only go here. If this point is A and if this point is B, then at what point at A or at B the electric field is more? This statements give me the answer for that question. So electric field at A and electric field at B, I have to insert greater than less than symbol. According to this statement, electric field at A is greater than electric field at B because electric field is directly proportional to density of field lines. Density of field lines. Electric field is directly proportional to density of the field lines, because the density of field lines here is greater than density of field lines here, because the lines are moving away from one another. You can see here, if here and here, this is A and this is B, A is what is the electric field at A is greater than electric field at B. That's what it is trying to explain us. Okay, so that was the thing. So this was about electric field lines. Now we will move to the properties of electric field lines. Okay, properties of electric field lines. So in all competitive examinations, we can see the questions based on the density part, which we had seen just before, and also properties of electric field lines, This is also important topic itself. Okay, so now let us see one by one topics. Right. The first property of electric field lines, they come out of positive charge and go into negative charge. If this is my positive charge and this is my negative charge, I'll place it far. And if this is my negative charge, electric field lines come out from this. They are coming out here. You can see here they are coming out. And electric field lines go into the negative charge. But electric field lines go into the negative charge, and but in the positive charge they go away from positive charge. Electric field lines go away. Here electric field lines come towards. This is simple concept. Okay, it's not rocket science at all. Okay, electric field, this is important to remember because application based questions will be asked in competitive part. Okay, now the second property. What is the second property? Tangent to field line at any point gives direction of field at that point. If this is my positive charge, and the tangents and the electric field lines are moving like this, okay, they'll be not moving like this at all. I'll show you the actual moments, actual trajectories. Okay, see, if they at this point the electric field in this is in this what I can say is in this direction. Okay, is in this direction, tangent to electric field. Okay, actually the electric fields are represented like this. For our understanding we will take it. Actually they are moved like this. If this is the positive charge, okay, this is the representation, actual representation. They are moving away from, because it is a positive charge, they are moving away from the positive charge. Okay, now at this point if I want to find the direction of electric field, direction of the field at this point, now I have to draw the tangent to that point. This is the tangent. If I want to find at this point, I have to draw the tangent at that point, then only I will get it. See, I have to draw the tangent. This is the direction. Okay, is this clear? This is also important property itself. Okay, field is the direction of tangent. Okay, field is the direction of tangent. This was the second property. We will see third property now. What is third property? Two electric field lines never intersect each other. Two electric field lines never intersect each other. Why? There arises a question, why? Two electric field lines never intersect each other because if they intersect, then there would be two tangents at that point. This would mean test charge will move in two different directions at point of intersection, which is not possible at all. See, if these are the two electric field lines I am having, okay, this is the electric field, here it is moving, this be positive, and they are moving away from the charge, as it is a positive charge. Okay, if these are the directions, now I'll take intersection of two electric charges, which is contradict. We are doing it contradictorily. At this point, at this sharp intersection point, what will be the direction of electric field? which line must I consider? Which electric field line must I consider? If I consider this line, it will be like this. Okay, and if I consider this line, it will be like this, which is never possible. A test charge, what is test charge? A 1 coulomb charge cannot move in two directions at all. It is absolutely false. It is not possible. Hence, two electric field lines never intersect each other. Two electric field lines never intersect each other. I'll just show intersection and cancel it, because of this reason the two electric field lines never intersect. This was our third property. Now we will move to fourth property. What is our fourth? Electric field lines are always normal to any conducting field. If this is my conducting field which has positive charge, if this is my conducting field which has positive charge, if this is my conducting field which has positive charge, then the electric field lines will be like this. They will be normal. What is normal? They are perpendicular to this surface. They are perpendicular to this, means 90 degree. They are perpendicular to this surface. Okay, that is the point. They are perpendicular. Okay. So this was the point, that is the fourth point. So next is our fifth point. There is fifth property. Fifth property. Electric field lines do not exist inside a conductor. See, if this is my conductor, let it be sphere. If this is my conductor, I'll take it as conductor. It creates confusion, of course. So let me take it as a conductor. If this is the conductor, then the electric field lines will not exist inside the conductor. Electric field lines will not exist inside the conductor. Will not exist inside the conductor. If the electric field lines will not exist inside, if someone is saying that the electric fields are going like this inside the conductor, it is absolutely false. It is absolutely false. Okay. If electric with in light of this statement, what will be the electric field inside the conductor? We have say electric field lines, we have said. Okay, electric field lines will not exist inside the conductor. Then what will be electric field? If electric field inside the conductor, electric field lines inside the conductor will not exist, then what is the electric field? Electric field equal to 0. Electric field is also equal to 0. That's it. Okay, that is much more important to understand, that electric field and electric field lines both are 0 inside the conductor. Both are 0 inside the conductor. Okay, right. This was our fifth property. Now we will move to sixth property. What is sixth property? Electric field lines never form closed loops while magnetic lines of force form closed loop. Electric field lines will never form a closed loop. What is closed loop? it will never, if this is the positive charge, it will never form a closed loop like this. Or if this is positive and this is negative, if this is negative, it is never possible. They will never form a closed loop like this. Loops are not possible. Okay, just remember that loops are not possible in electric field. Okay. This was our sixth property. Seventh property. These properties are very much important for all competitive and board level also. In MCQ's part, they may ask these properties. Now we will move to seventh property. What is seventh property? Number of lines originating or terminating on a charge is proportional to magnitude of charge. If number of lines is more, then magnitude of charge will be more. See, if this is charge Q and if this is charge, okay, I'll take this is charge Q1 and this is Q2. Number of lines nodri. If this is 1, 2, 3, 4, 5 and 6, and here see, by observation only we can say that by the property, seventh property, number of lines originating or terminating on a charge is proportional to magnitude of charge. It means that Q2, it means that what it means, it means that Q2 is greater than Q1. Why Q2 is greater than Q1? Because of seventh property, that is the number of charge is directly proportional to, not number of charge, sorry, charge is directly proportional to number of field lines. Originating or terminating. Originating or terminating. Is this clear? This is a very important thing. Is this clear? It is very important topic. We can again, you can see the seventh property again afterwards, after the complete lecture, if you are not understanding. Okay, very important topic. Number of lines of force per unit area normal to area at a point represents magnitude of intensity. It means that electric field is directly proportional to number of field lines by area. It is eighth property. It is eighth property. What is eighth property? Electric field is directly proportional to number of field lines, number of field lines divided by its lines. Okay, understand, it is lines. Okay, number of field lines divided by area. Number of field lines by area. What it means? If I am taking a positive negative charge, I will take negative charge. From that time I am taking positive charge. Just is for negative. Okay. Why I am drawing like this arrows? Because according to first property, in light of the first property. See, if this is the thing, if this is the thing, this will be followed here also. See, if I am taking electric field here and electric field at here, okay, electric field here and here, what is area here and which area is greater? This is area 1 and this is area 2. Of course, area 1 is greater than area 2. Number of electric fields at both points I am taking 2 only. Here also I am taking 2 only. Okay, 2. Number of electric fields are, electric field lines are 2. Number is equal to 2. Number is equal to 2. If number is equals to 2, then where the electric field is greater? As area is greater at A, at E1, then inversely proportional, then electric field at, this is electric field E1 and E2 if I am taking, then what is the relation of E1 and E2? Electric field at 1 is less than electric field at 2 because area is greater and number of field lines are equal at both the points. Okay, so that is what we are getting. Okay, right. These were the properties, 8 properties of an electric field lines. Okay, now we have types of fields also, which is not in JEE portion or other all competitive portions. Just we will see some more important points, on the electric field lines. Okay, let us see some more points on this electric field lines itself. Okay, see, these will be important points. This will just clear your conceptual understanding about electric field, but this is important as competitive preparations and competitive questions will stress on this type of concepts. Let us understand the concept first. Electric field lines into different charge configurations. See, if here I am taking a positive charge, if here I am taking a positive charge and here I am taking a negative charge, positive and negative charges. Okay, due to positive charge, the field lines electric field lines are moving away. Is this clear? Electric field lines are moving away and they are perpendicular to the surface, normal. Okay, here what is the thing, electric fields are coming into the charge, means moving towards the charge. This is first point. Okay, this is simple first point. Okay, now if I take positive charge here, now I am taking positive negative configuration. If I am taking a positive charge here and a negative charge here, then what about electric field lines? Positive negative configuration, electric field lines will move like this. Okay, these are not forming a closed loop. Okay, and from here also the fields are going. And from here the field lines are coming towards. This is a second configuration. This is second configuration. Next configuration is positive positive. If I am taking positive configuration, if I am taking positive, here also positive and here also positive, what will happen? Just think, pause the video and think and try to guess. Okay, due to positive charges will repel each other. If they are repelling, fields also will repel, then the electric field lines will be going like this. Okay, and here electric field lines are moving away. both are away. Okay, they are moving away from the charges. There is no field here. Okay, there will be no field here. Is this clear? Very important. Okay, sorry. If this is clear, then we will move to next configuration. Now next is negative negative. What if I'm having negative negative? Same as that of that thing, same as that of that thing. Is this clear? So the same will be followed here also. Here it will move like this, like this. Sorry. So but here the only change is that the lines, field lines are coming inside. They are coming inside. Is this clear? Is this clear? Here they are coming inside. That's it. But in negative negative configuration they were moving outside. This clear? Okay. That was the thing. Okay, so that was all about electric fields lines. So thank you for watching.